Welcome friends to the part 3 of the module on null hypothesis and alternative hypothesis. In this part we are going to discuss about combinatorial hypotheses. What it means? It is something like a combination of different hypotheses what we discussed in part 2. In part 2 we have explained simple and null, simple and composite, null and alternative, parametric and non-parametric, and it is something like an extension of all these with different combinations. This combinatorial hypothesis, we can say that there are 8 categories comes under simple and null hypothesis, composite and null hypothesis, simple and alternative hypothesis, composite and alternative hypothesis, parametric null hypothesis and parametric alternative hypothesis, further non-parametric null hypothesis as well non-parametric alternative hypothesis. So, these are the 8 combinations we are going to discuss with using that simple and composite, null and alternative, parametric and non-parametric. Now, coming to this one, simple null hypothesis, as I mentioned that it is as so clear, it completely specifies the population distribution without ambiguity. If you see this, the null hypothesis which is mentioned as H naught such that mu equal to mu naught and H naught such that sigma equal to sigma naught, in which my mentioning about the population, normal population is having 2 parameters mu and sigma. So, therefore, both are mentioned in this statement, then only you call it as simple, and they as they are equation type. Null hypothesis is equation type. Simple means both parameters are covered. So, this is the example for simple null hypothesis. Now, coming to the composite null hypothesis, you may mention one hypothesis, means one parameter may be mentioned, one parameters may be skipped. So, composite hypothesis is one of that does not completely specify the population distribution. For example, in a normal population there the 2 parameters will be there, mu and sigma. If you mention only one, it is incomplete statement, we call it as composite. For instance, if I am saying that mu is not equal to mu naught and H naught such that sigma equal to sigma naught, here what happened, I am mentioning H naught as a alternative hypothesis which is not null hypothesis, right. H naught sigma equal to sigma naught, it is the null hypothesis and simple. So, therefore, these combined together we call it as composite null hypothesis. Coming to the second case also, first one is clear, second one is ambiguous. So, therefore, you call it as composite null hypothesis. Coming to the third statement, mu is not equal to mu naught and sigma is not equal to sigma naught, complete ambiguity is there. So, therefore, you call it as composite but null hypothesis. So, simple null hypothesis is something like it includes one independent variable and one dependent variable. Null hypothesis is something like a simple and unbiased or neutral statement. This is the way you have to understand what do we mean by simple hypothesis, what do we mean by null hypothesis, and what do we mean by combining these two, simple and null, it is something like that. So, a statistical hypothesis which is simple as well as using for neutral statement, then you call it as simple null hypothesis. Coming to the examples of that, where you are saying that, for example, population mean is 60, I am simply mentioning mu equal to mu naught, it is a simple null hypothesis. Similarly, if you are comparing two population means, the statement is something like this, H naught such that mu 1 equal to mu 2 is also considered to be simple null hypothesis. If you are comparing the two proportions, then this is the statement we call it as simple null hypothesis. What do you mean by composite null hypothesis? Already I have given null hypothesis description, therefore, I am simply mentioning what is composite hypothesis and composite null hypothesis separately. Coming to the simple alternative hypothesis, the meaning wise it should be unambiguous and it should be complicated. In that sense, an inverse hypothesis of a null hypothesis is called alternative and it should be unambiguous, then only you call it as simple alternative hypothesis. So, it will be useful for deciding the nature of the test also. Simply the alternative hypothesis meant for deciding the type of test, whether it is one tail test or two tail test. So, depends on the alternative hypothesis only we can categorize whether it is left tail test or one tail test, right tail test. Simple alternative hypothesis examples. For instance, H0 such that mu equal to 0 versus H1 also equal to mu equal to 10. What it means that null hypothesis is mentioned in simple format, alternative hypothesis is also mentioned in simple format. In that case, you can call it as simple alternative hypothesis. Composite alternative hypothesis meaning wise as that alternative hypothesis which is ambiguous or more dealing with more than two variables. So, if you see that H0 such that versus H1 such that mu greater than 0 means mu greater than how much greater, there is no clarity. If you say that mu less than 0, how much less it is, that is also no clarity. Therefore, you call it as composite. Alternative usually denoted with H1. Now, parametric null hypothesis is a null hypothesis which is a measurable phenomenon, meaning wise you call it as parametric hypothesis. And examples wise, if you say that there should be a parameter, for example, if sample follows normal population, the normal distribution is having the parameters mu and sigma. So, therefore, that mu and sigma if you mention completely, then you call it as without any ambiguity with a neutral format, you call it as the parameter is there in the statement as well as in the statement that is unambiguous, neutral, impartial. So, therefore, any hypothesis which is having the properties like it should be a parameter as well as neutral, you call it as parametric null hypothesis. Non-parametric hypothesis is something like a hypothesis, non-parametric null hypothesis is a combination of null and non-parametric where you need not have the measures. Only quality characteristics or attributes we are considering for framing the hypothesis. Of course, if you have in neutrality you are maintaining, then it is called null hypothesis. So, a neutral hypothesis with characteristics you call it as non-parametric hypothesis as a meaning. Now, coming to the examples, if you say like this, let the population consists of some attributes of study and the objective is to study agreement between the attributes. Attributes like what is that? For instance, null hypothesis may be there is no association between attributes, there is no probability distribution is not good fit. When you say something like that, that statements you call it as non-parametric null hypothesis. So, this is the example. Parametric alternative hypothesis, what it means? As the name itself, it has to satisfy two characteristics. It should be parametric as well as alternative. Parametric means a measurable phenomena should be there, alternative means inverse null hypothesis. So, an alternative hypothesis with parameter or a population measures constraints is called parametric null hypothesis. It is an inverse statement of null hypothesis with parameters of probability distributions of the parent population. So, this is comes under the category of parametric alternative hypothesis. Coming to the examples, if you say this, let us sample belong to the population having normal distribution with mean mu and variance sigma square. Of this population, the parametric alternative means that hypothesis that consisting parameter, alternative means it should be non-null. For instance, H1 mu less than mu 1. So, mu is a parameter, but it was given as alternative statement. Similarly, mu is not equal to mu 1 and sigma is less than sigma 1, sigma is not equal to sigma 1. If you say these statements are resembling the parametric alternative hypothesis. Why? Because there is a parameter as well as alternative hypothesis is there. Now, coming to the non-parametric alternative hypothesis, as I mentioned that without parameter means with using the characteristics or attributes as an alternative hypothesis, you call it as alternative hypothesis, but non-parametric. So, it is a hypothesis which deals with qualitative characteristics or attributes. So, this is a decision making statement with quality characteristics of the population under study. So, examples are concerned, let the population consists of some attributes of study and the objective is to study the agreement between the attributes, then you call it as non-parametric alternative hypothesis. So, coming to the conclusion of this part, in the last part I have discussed about the phenomena of combinatorial hypotheses. What this combinatorial hypothesis says that we have the parametric hypothesis, non-parametric hypothesis and null and alternative hypothesis, simple and composite hypothesis. With a combination of all these things, we have discussed the framing, the structure, the importance, the significance and with examples. So, in summary, we can safely claim that part 1 deals with what is the significance of sample space, acceptance region, critical region. Part 2 deals with what are the simple hypotheses and composite hypotheses, alternative and null hypothesis, parametric and non-parametric hypothesis along with different statistical hypotheses. Part 3 deals with combination of all these hypotheses. This is what we discussed in this module on the title with null and alternative hypothesis. Thank you.